Hi, this is the part 4.1 of modeling in spatial relations, and in this part we'll discuss the result interpretation which we will get from OLS. And OLS is ordinary least square method of regression. Down is something about me. I'm Dr. Zubairul Islam. I'm working in the Department of Geography in Adigrat University, Ethiopia. So the arc map is open here, and on the left side is the data, right side is the R toolbox. So the data is here now. I am not using the zone data, I'm using the urban centers. And all these are the around 650 centers. And there are 2-3 reasons to change my data because number of data, the number of observations will be more. We can change the data, we can manipulate, and there are some errors, there are some outliers. So how, if we will remove the errors, then what will be the change in the results? So this is the reason why I'm using some different data here. So here ordinary least squares, thereafter I will take the feature class, then I will give the unique ID. The dependent data I will give here, that is the GDP data. In the explanatory part, I will give the population of 2015 to explain the GDP, and I will take the built up area 2015. I want the report because this report will help me to understand. Okay, let's take the PG, save it, and this report will help me to know about this model, whether I should accept it or not. So let's do it. Okay. So this is the result. We have got the result, and you will find 3 things here. First is the in map form here. This is the information produced, and when you will see this information or the result, you can open the attribute table. This is the GDP data. This is built up. This is population. And last 3 are estimated values of GDP based on built up and population. And when you will GDP observed minus estimated based on population and built up will be the residual. So these residuals, what they did, they standardized here. So just to see that here minus 2.4, what does it mean? It means that the observation is here. This is the observation, but estimated is more. Estimated is more. So observed minus estimated is the residual. So in relation with built up and population, in this center, the GDP is less. And what is the center? The center is here. And what is the color? Color is blue. So it is clear that the blue color is showing those areas where the GDP is less than expected. Then naturally, on the other hand, this red color will be showing that where the GDP is higher than estimated based on population and build up. So I took only 2 explanatory variables. You can take more, so it will give you more information, because explanatory variables explains, they tell the story. Okay, there is much more in this story which we'll get in our report. So second thing, what you can see is, you can see the result part, and you will choose the geoprocessing, you will find the results, current session, and this is OLS, and in the message you can see the key information related to the results. But all this information is given in the detail in PDF, which we opted that I want my report in PDF form. So let's see that PDF. So the PDF is right here. There are two important parts which we must know is the summary of OLS result. This is the summary. And the second is OLS diagnostics. So these two informations and these are the notes given for interpretation. The important information is where this asterisk is given. This symbol means that here that is statistically significant. This is statistically significant, this is significant, this is significant. But what is this? Okay, we know about R squared value, but this is also important to know the F statistics, the joint word statistics, Coincur statistics, and Jerk-Bera statistics. All these statistics will confirm you that whether your model is fine or not. So related to OLS diagnostic and the summary, we will discuss one by one. We'll take first thing first, then we'll go to second, third, fourth, fifth. So in this report, major 5 or 6 things are very important to know in a order. So that order I have made it here. Okay, let's see that order. What I did, I copied and pasted these two informations, summary and OLS. I copied and I made an image. So here I have copied and pasted here, and this is first thing which we should see is the multiple R squared or adjusted R square. This information will assure you the model performance. Where is the model performance is what? Here there are two values, multiple R squared and adjusted R square. So these values, the measurement of the model performance, and these values, possible values ranges from it may be 0 to 1. So the adjusted R square value is always a bit lower than adjusted R value is bit lower than 453, 459. Means this value is bit lesser than multiple R squared, because this means it relates to the data and is consequently a more accurate measure of model performance. So this adjusted R square is giving us more information about the model than multiple R square. So it is advisable to be dependent on adjusted R square when the model performance is concerned. So if you are adding an additional explanatory variable, then what happens? Model may likely increase the multiple R squared, but may decrease the adjusted R square value. Suppose you are creating a regression model of anything. So if you are adding some explanatory variables more, then maybe multiple R square may increase, but it may decrease because it is including another aspects also. So the important thing is what R square is explaining here. What performance? What does it mean? It means that as per this result, population and built-up area are explaining how much 84% variability in the GDP data of the urban centers. So in other words, we can say that explanatory variables are explaining 84% story of the GDP during 2015. So If it is less, means explanation is less by explanatory variables. If it is more, then explanatory variables are helping us to make us confident that okay, that this variability is because of these explanatory variables here. So this is the purpose of to see, if you want to see the model performance, then this is the first thing which you should see in your result. And thereafter, the second thing which is important is summary of OLS results. So what is the summary here? Summary of OLS results. The first is the column of variable, coefficient, standard error, statistics, probability, robust, like this. So variable is here. This is overall intercept. This is the explanatory variable, built-up area. This is population. Please listen me carefully here. What does it mean? 657 means what? What this coefficient will tell you? It will tell you that if one person is added, it will give you $657 USD. Okay, so this is the relation of population and GDP 2015. So the one person means here 657 USD. Similarly, here you can see that built-up area, okay, if 1 square, because the unit is the same, okay, their unit is in square kilometer. So here, if 1 square kilometer is added, it will add as much USD. This is the coefficient. So in simple words, you can say like this. And thereafter, this is the coefficient here, then standard error. Standard error should be less, and this is here a coefficient divided by standard error. You will get the t statistic. Once you get the t statistics, then based on the degree of freedom, you will see the probability. So here in this case, this symbol, here's this symbol, this symbol, this symbol, all the symbols are showing that your results are statistically significant. But there are more another things which you must know about this result. The third one is showing the model significance. The third one will help you to understand and to assess the model significance. Both the join F statistics here and join world statistic are the measure of overall model statistical significance. So the joint F statistic is trustworthy only when the Coincur statistics is not statistically significant. Okay, then it is important. If you will see this Coincur statistic here, it is not statistically significant here, clear, because there is no symbol given. So when it is not statistically significant, then this joint F statistics is important. Okay, then it is trustworthy. If the Coincur statistic is significant, then you should consult the joint world statistic. Then you should see this joint world statistic. Okay, otherwise no need. Means again, listen to me. If Coincur statistic, you can see here Coincur statistic is significant, then you should consult the joint world statistic. Joint world statistic is to determine the overall model significance. So uh, so the null hypothesis for both of these, for both of these tests, means joint F and joint Wald test, is that explanatory variable in the model are not effective. This will be the hypothesis for both the tests, that explanatory variables are not effective. So in both the cases, these two symbols are cleared, showing us that we have to reject the null hypothesis because our p-value is very less, extremely less here, and we can say at more than 99% confidence level that our explanatory variables are highly effective to explain our dependent variable, that is GDP data here. Okay, so this is overall performance of the model. So as per this result, this performance is fantastic. And number fourth is the Coincur statistic. Here, for what this statistics we are using? We are using this statistics to check the stationarity. How much our data is stationary? What does it mean? Suppose maybe if we are working on some data uh, like there may be minimum data, minimum value data, middle value data, and maximum value data. Means if you can classify the you can classify like the population data. There will be some towns where the population is less. There may be some towns where population is more, and there are some moderate areas. So in suppose in moderate area, the model is very nice. It is giving you the means observed and estimation. There is no much difference. But those areas where population is very high, there is a gap. So it is not stationarity. Stationarity is not there. So for that very purpose, Coincur statistics help us to understand the stationarity. Now I'm coming to the very important point, that what is the null hypothesis here? The null hypothesis for Coincur statistic uh, is that the model is stationary. Model is stationary. So okay, so degree, with this degree of freedom here, the probability should be more than chi squared, but here if you will see the table of chi-square, then you will find that you cannot reject this null hypothesis. Means your null hypothesis will be the data is here. The null hypothesis is this, that the test, this test is that the model is stationary. This model is stationary. This is null hypothesis. Here there is no symbol, so we cannot reject this null hypothesis. We have to accept this null hypothesis, and we have to say that this test is in this test the model is stationary. Okay, fine. Now I am coming to the fifth point, and the fifth point will help us to understand the model model is biased or unbiased. What does it mean that model is biased or unbiased? And this is the Jerk-Bera statistic, okay? And this is statistically significant. What does it mean? Jerk-Bera statistics indicate whether or not the residuals. Here we are talking about the residuals. Means residual means what? Observed minus estimated values are normally distributed. Are these normally distributed? So the null hypothesis for this test is that the residuals are normally distributed. The jerk-Barre statistic means the null hypothesis for this is this, that residuals are normally distributed. So if if you were to conduct a histogram of these residuals, they would resemble the classical bell. Okay, if this null hypothesis is not rejected. So null hypothesis, again I'm telling you for this test, is that the residuals are normally distributed. So in this case, in our result, this is statistically significant, p-value is less, then we will reject the null hypothesis. And what does it mean? That our residuals are not especially, I mean not normally distributed. So the residuals are not normally distributed, indicate your model is little biased. So that biasness is something which shows that there is something which is missing in explanatory variable. There is something which is missing where in explanatory variables. So we can see it here, and thereafter in the fifth itself it is given the spatial autocorrelation. Okay, so this is clear that this model is biased. How you can see? Okay, you can see like this. You can see like this. P, when you will see here, okay, yes, then here you can go to the symbology and you can go to the classifier, just see the standard deviation maybe. So you see one value. Okay, what I'm using here, I have a standard residual. Okay, standard residual. Then when I will classify with standard deviation, then this is not a normal distribution. You can see here more tail is towards the right side. You see here more tail is towards the right side. So this is not the normal. It means your residuals are not normally distributed. Means this is little, your model is little biased towards right side values here. Right side values. So this is the way you can see. And another method, just to check your residuals whether it is normally distributed, means, or some values are concentrated at one location, means whether your some values are overestimated and underestimated. Then overestimated will give you higher residuals, and underestimated will give you maybe some another residual. So how to check that thing? How to check? So for checking, this is the way you can check analyzing pattern and spatial autocorrelation. So when you will give you want to see the spatial autocorrelation with the help of standard residual, then you can say that okay, generate the report. Here this is the optional, I'm not giving, I just want to see that what is the pattern here. Do it okay. So this is the result of spatial autocorrelation, and from the result you can see that your data means the higher and lower values are clustered here. So this is the way you can see with the help of residuals. You can see that whether residuals are clustered. So your data shows that yes, these are the clusters. So so in this report, which I was talking about all these values, first to 6 I have already covered. So you practice with the help of data given to you, and you can see your results. And if there is some outlier, like in this data here, you can see, okay, this is the model here, okay, this is the regression line for built up and population, and you can see that most of the values are down, and there is one value which is very up, very up. So this value is showing the Addis Ababa. Okay, Addis Ababa in terms of population and built up area is far different from another urban centers. So this is the reason why this point is so far from the another points. But now another question is that if, what shall we do? Shall we remove Addis Ababa? If we are removing Addis Ababa, then what will be the effect? Then of course it is not advisable and it is not correct that if you know that your data is correct and this is not a mistake, so you should not remove the outlier, or you should not remove the higher end or lower values. Sometimes because of the lower values there is a problem, because of extremely higher value there is a problem. But if you think that these lower and higher values is not the mistake, so do not remove it, otherwise you will get a lesser information. Okay, this is the histogram of your standard residual. Here you can see that on the right hand side your tail is more. I think this 12 point, maybe it may belong to some areas. Okay, so it shows the residual versus predicted plots. Means if your points, if your values are close to this line, there is no much gap. But if some points are far from this line, means there is some over and underestimation. So okay, so let me repeat it briefly. R square is giving you about the about your model, how much explanation is being done. With the help of population and built up area, you got 84% explanation. Okay, and these two statistics are very important to you, and if this is null hypothesis not rejected, means your data is stationary and you can see the F statistic here. If it is rejected, then you have to see world statistics. So in both the cases the result is perfect in favor of the model. And the next is this Jerk-Bera statistic. Here it shows that the null hypothesis for this test is that your data is means the predicted values are not are normally distributed, but here it is statistically significant that you have to reject the null hypothesis. And here you can say that what does it mean, that your residuals are not normally distributed, and that you have seen here. So this is not the end of the story, and there are so many things are in your hand. You can increase the explanatory variables, you can decrease the explanatory variables, and somewhere if you find that okay, there is some data error, then you can remove that error. Thereafter you can see your result, and when your model is satisfied, then important thing is that there is archaic information criteria. How you will come to know that your overall model means your explanatory variables are doing fine. So as if you this result is based on two explanatory variables. Suppose you have given 3, 4, 5, 6. So whatever explanatory variables, what combination is giving you less AICC value. So from the explanatory variables, when you are getting the least AICC value, means that model is the best for you. This is the thumb rule for this archaic information criteria. So we have discussed about these results. Just you practice and with the help of data, the same data, and good luck for your practice. And it's enough for now. Thank you so much.